Good morning. We are continuing with module 3, Centroid. So today we will discuss centroid of semicircle, triangle, circle and quadrant. So here you can see a semicircle of radius r. So with respect to the y axis, the x coordinate of the centroid. So this distance is equal to radius r. And with respect to the OX axis, y coordinate is equal to 4r by 3 pi. So next is a triangle. So here we assume the base width as b, height is equal to h. This is a right triangle. So with respect to the OY axis, the x coordinate is equal to b by 3 and y coordinate is equal to h by 3. So you have to by heart these values. The derivation is not included in your syllabus. So next is a quadrant. So for the quadrant, the x coordinate, that is the distance from the OY axis to the centroid is 4r by 3 pi. So here we assume r as the radius of the quadrant. And y coordinate, that is with respect to the OX axis, is taken as 4r by 3 pi. And for the circle, with respect to the OY axis, x coordinate is r and y coordinate is also r. So r represents the radius of the circle. So now we will see how to calculate the centroid of a composite section, which include a semicircle, rectangle and a triangle. So you can assume all the dimensions in millimeter. So the first step is you have to draw the reference axis. So the extreme left line is taken as the OY axis and the bottom line is the OX axis. So these are the reference lines. So you have to draw the reference line. Otherwise you won't get mark. So the first step is you have to draw the reference line. So now the next step is you have to split this into simple figures. So this figure include a triangle, then a rectangle and a semicircle. So here the height is given as 4. That is the diameter of the semicircle, and this width is given as 6. So up to this it is 6 and this is 3. That is base width of the triangle, right triangle is given as 3. So now you have to write the area of the first figure. You can assume this as the first figure, this is the second figure and this is your third figure. So area A1 is a semicircle. So the area of the semicircle is pi r square by 2. That is equal to pi into radius is 4 by 2. So 2 square by 2. That is equal to 6.28 millimeter square. So next is A2, that is second figure is a rectangle. So here the base width is 6 and the height is 4. So 6 into 4, that is equal to 24. So now A3, that is the area of the triangle. So area of the triangle is equal to half into base into altitude. So here the base width is 3 and the height is 4. So half into 3 into 4. That is equal to 6 millimeter square. So here also millimeter square. So now the next step is you have to find the distance of the centroid. So we are taking the semicircle. So now we have to place the semicircle like this. So now the distance of the centroid from the reference axis OY, that is this distance. So you know this distance is equal to the radius R. So that radius minus 4r by 3 pi. So that will give this distance. So x1 is equal to total length up to this is radius r. So r minus this length 4r by 3 pi, that will give the distance of the centroid from the OY axis. So r minus 4r by 3 pi. So now you have to calculate y1, that is the distance of the centroid from the OX axis. So this is y, that is equal to the radius of the semicircle. That is equal to radius is 2. So here you have to calculate the value 2 minus 4 into 2 by 3 pi. So that is equal to 1.151 millimeter. So now for the second figure is a rectangle. So now the CG of the rectangle from this end, this is equal to b by 2. So you have to measure the distance of the centroid from the OY axis. So this is equal to the radius, that is 2. This length is equal to 2. 2 plus this total length is 6. 6 by 2, that is 3. So x2 is equal to 2 plus b by 2. B is equal to 6. 6 by 2, that is equal to 5 millimeter. So next is y2. So distance of the centroid from the OX axis, this is equal to d by 2. So total depth of the rectangle is 4. 4 by 2, that is equal to 2 millimeter. So now for the triangle, you have to place the triangle like this. So now from this edge, that is from the left edge of the triangle, this length is equal to b by 3. So here you have to measure the distance of the centroid. This is the centroid, distance of the centroid from the OY axis. So this is equal to 2, this is equal to 6 plus b by 3. So here x3 is equal to 2 plus 6 plus b by 3, that is 3 by 3. That is equal to 9 millimeter. So I am measuring from the OY axis to the centroid. So this is 2, this is 6 and this is equal to b by 3. b is 3, 3 by 3 is 1. So next is y3. y3, that is equal to the height by 3. Height is 4. 4 by 3. 4 by 3. So now you have to substitute all the values in the equation. So you have to write the equation based on the question. X bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So this is equal to 6.28 into x1, that is 1.151, plus a2 is equal to 24 into 5 plus 6 into 9 divided by 6.28 plus 24 plus 6. So this is equal to 2.995 millimeter. Sorry, 4.995 millimeter. So now y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. That is equal to 6.28 into y1, that is equal to 2, plus 24 into y2, that is 2, plus 6 into y3, that is 4 by 3, divided by 6.28 plus 24 plus 6, that is equal to 1.890 millimeter. So now in the second question, you are given an axis. So with respect to the axis, you have to calculate the centroid. So the axis is given, this is the OX axis and this is the OY axis. So with respect to this given axis, you have to calculate the centroid. So here also we are splitting it into three figures. This is your first figure, second figure, and this is the third figure. So you can write first one, area is equal to, that is previous question, it is 6.28 millimeter square, that is pi r square by 2. So pi into 2 square by 2. So a2 is equal to 6 into 4, that is this area, 6 into 4, that is 24 millimeter square. And now a3 is equal to half into base is 3, height is 4. So half into base into altitude, half into 3 into 4, that is 6 millimeter square. Now you have to calculate x1. So here the reference axis is shifted to the new position. This is the new position of the reference axis OY. So with respect to this axis, you have to calculate the centroid. So you have to place the semicircle. So now with respect to this OY axis, centroid is here. So two figures are to the right side and one figure is to the left. So here this figure, centroid of this figure is to the left. So here x1 is equal to this distance, that is equal to negative value minus 4r by 3 pi. That is equal to minus 0.849. And now y1. So y1 is measured with respect to this reference axis. So this is the reference axis, that is same as the previous case. So here this is the reference axis. So with respect to this axis, centroid is at a distance radius r. So this is r, that is equal to 2, and unit is millimeter. Now for the second figure, so you have to place the triangle. So with respect to this new axis, centroid is at this distance. So that is equal to b by 2. So x2 is equal to b. Total width is 6 by 2, that is 3 millimeter. And y2 is with respect to this OX axis, that is this distance. that is equal to d by 2. D is 4. So 4 by 2 is equal to 2 millimeter. So next is a triangle. So with respect to this OY axis, centroid is here. So we have to measure this length. This is 6. 6 plus this length is equal to b by 3. So x3 is equal to 6 plus b by 3. That is b is equal to 3. 3 by 3. That is equal to 7. So now y3 is equal to y3 is equal to this length, that is equal to h by 3, same as the previous case, h by 3, that is 4 by 3, that is 1.33 millimeter. So now you have to write the equation to calculate x bar and y bar. X bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So that is equal to 6.28 into minus 0.849 plus 24 into 3 plus 6 into 7 divided by 6.28 plus 24 plus 6. So that is equal to 2.995 millimeter. And now y bar is equal to a1 by 1 plus a2 by 2 plus a3 by 3 divided by a1 plus a2 plus a3, that is equal to 6.28 into 2 plus 24 into 2 plus 6 into 1.33 divided by 6.28 plus 24 plus 6. That is same as the previous case, 1.890 millimeter. So sometimes you will be provided with the reference axis. In that case, you have to measure all the coordinates with respect to the given axis. So if in the question it is, if this axis is not mentioned in the question, then you have to choose the reference axis. So always we have to choose bottom line as the reference axis for calculating y coordinate, and extreme left line is used to calculate the x coordinate of the figure. So next we will see the centroid of an L section with respect to the given axis. So here the axis is given in the question. This is the OX axis and this is the OY axis. So with respect to this axis, you have to calculate the centroid. So it is made up of two rectangles. You have to split into two rectangles. This is your first rectangle and this is your second rectangle. So now the first step is you have to write the area. A1 is equal to 250 into 12. That is equal to 3000 millimeter square. Then A2 is equal to, this total length is 200. You have to deduct this width, that is equal to 12. So 200 minus 12 into 12, that is equal to 2256 millimeter square. So now the next step is you have to write the centroid. So you have to place a rectangle like this, and you are measuring the x coordinate with respect to this OY axis. So that is equal to b by 2. So base width is 12. So 12 by 2. So x1 is equal to 6 millimeter. And now y1 is measured with respect to this reference axis. So this is equal to d by 2 and this is also d by 2. So 250 by 2. So that is y1. So now next you have to calculate x2. So now this is the second rectangle. So here the width is equal to 200 minus 12 and depth is equal to 12. So now with respect to this reference axis you have to measure x2. So this is equal to 12. 12 plus this width by 2. So x2 is equal to 12 plus 200 minus 12. That is 188. 188 by 2. So now y2. y2 is measured with respect to this OX axis. So this is d by 2 and this is also d by 2. So you are measuring this distance. That is from the OX axis. That is equal to 12 by 2. That is equal to 6 millimeter. So now you have to write the equation. X bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. So you have to substitute all this value and you have to calculate the final value. Y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. So you have to complete this one. So next we will see how to calculate the centroid of this composite section. So this composite section consists of quadrant and a semicircle. So first step is you have to draw the reference axis. So this is the OY axis and this is the OX axis. So here the radius of the quadrant is given as 10 centimeter. So the area of the quadrant, you can assume first figure as the quadrant, second one as the semicircle. So area of the quadrant is equal to pi into r square. R is equal to 10. R square by 4. That is equal to 78.54 centimeter square. So next you can calculate the area of the semicircle. So area of the semicircle is equal to pi into r square by 2. So here r is equal to 5 centimeter. So pi into 5 square by 2. That is equal to 39.27 centimeter square. So next step is you have to calculate the position of the centroid x1 and y1. Then you have to calculate x2 and y2. So for the quadrant, if the reference axis is OX and OY, then the coordinates of the centroid are at a distance. X coordinate is 4r by 3 pi from the reference axis OY, and the y coordinate is at a distance 4r by 3 pi with respect to the OX axis. So now you can place this quadrant here. So centroid of the quadrant is at a distance x bar is equal to 4r by 3 pi. That is x1 is equal to 4r by 3 pi. So here r is equal to 10. So 4 into 10 by 3 pi. That is equal to 4.24 centimeter. So now here y bar is equal to again 4r by 3 pi, which is measured with respect to the OX axis. So y1 is equal to 4r by 3 pi. That is equal to 4 into 10 by 3 pi. That is again 4.24 centimeter. So next for the semicircle. So for the semicircle, with respect to the OY axis, x coordinate is at a distance r and y coordinate with respect to the OX axis is 4r by 3 pi. So here you have to place the figure. So with respect to the OX and OY axis, x coordinate is at a distance r. That is x2 is equal to r. That is equal to 5 centimeter. And the y coordinate with respect to this OX axis, that is 4r by 3 pi. 4r by 3 pi. So here the radius is equal to 5. So radius is given as 5. So 4 into 5 by 3 pi. That is equal to 2.12 centimeter. So here you are calculating the centroid of the shaded portion. Your equation is x bar is equal to a1 x1 minus a2 x2 divided by a1 minus a2. So you have to substitute all the value. 78.54 into 4.24 minus 39.27 into 5 divided by 78.5 minus 39.27. So that is equal to 3.48 centimeter. So next y coordinate. Y coordinate is equal to a1 y1 minus a2 y2 divided by a1 minus a2. That is equal to 78.54 into y1. Y1 is equal to 4.24 minus 39.27 into y2 is equal to 2.12 divided by a1. That is 78.54 minus a2 is equal to 39.27. That is equal to 6.36 centimeter. So next we will see the calculation of centroid of this composite section. So this is a bigger section. So here first step is you have to draw the reference axis. So this is your OY axis and this is your OX axis. So next step is you have to complete this figure. So here you have to calculate the centroid of this portion. That is, you have to calculate the centroid of this shaded portion. So in order to calculate the centroid of this shaded portion from this rectangle. So from this rectangle you have to deduct this triangle, this quadrant, then again this triangle and the circle. So first figure will be rectangle. Second figure you can assume as the circle. So this is your second figure. Third one you can assume quadrant. Fourth one this triangle. Fifth one this one. So first figure is this rectangle. So from the rectangle you have to deduct this triangle, quadrant, circle and this triangle. So now the first step is you have to calculate the area. So first figure is rectangle. So A1 is equal to, this total length is equal to so here this length is given, this length is also given in the question, this is 30. So now the total width of the rectangle is 35 plus 30 plus 35, that is equal to 100. So area of the rectangle is width into depth. So width is equal to 100. Then the depth is equal to 100 plus 35. So this 100 plus 35. So into 135. That is equal to 13500. So all the dimensions are in centimeter. So unit is centimeter square. So second figure is circle. So A2 is equal to area of the circle. So here the diameter of the circle is given, that is equal to 30 centimeter. So area of the circle is equal to pi into r square, that is equal to pi into 15 square. Radius is 15. That is equal to 706.5 centimeter square. So now the third figure is the quadrant. So here the radius of the quadrant is given as 35. So third figure is quadrant. So A3 is equal to pi into r square by 4. That is equal to pi into radius is 35 square divided by 4. So the fourth figure is this triangle. So here the width of the triangle is 35, depth is equal to 35. So the area of the triangle. So area A4 is equal to half into base width 35 into depth is again 35. And the fifth figure is again the triangle whose base width is 30 and depth is 70. So here A5 is equal to half into base width into depth. Base width is 30 and depth is equal to 70. So these are the 5 figures. So the next step is you have to calculate the position of the centroid. So first figure is this rectangle. So for the rectangle, its centroid is at the geometric center. So this width is equal to 100. So centroid is at a distance 100 by 2. So x1, that is measured with respect to the OY axis. So centroid will be located at the geometric center of this rectangle. So this width is equal to 50. X1 is equal to 50 and Y1 is equal to, that is the distance from the x axis to the centroid. So this total depth, that is equal to 135. So centroid is at a distance 135 by 2. 135 by 2. So Y1 is 135 by 2, that is equal to 67.5 centimeter. So maybe the centroid is just below this point. Maybe it will come here. 67.5 is this distance. So now the next is the circle. So for this circle, the centroidal distance is given. So this is the centroid of the circle, that is the diameter of the circle is 30. So this is the centroid. So here this distance are given in the question. So this is the x coordinate with respect to y axis. X coordinate is 50 and y coordinate is also given in the question. Y coordinate is this length, that is 70. So x2 is equal to 50 centimeter and y2 is equal to 70 centimeter. x2 is equal to 50 and y2 is equal to 70. So next figure is the quadrant. So with respect to the OX axis, centroid is at a distance 4r by 3 pi. That is, the y coordinate of the centroid is 4r by 3 pi and the x coordinate with respect to this axis is 4r by 3 pi. So here in this figure you have to keep like this. So now this distance is equal to 4r by 3 pi. We have to get the centroidal distance with respect to the OY axis. So this total length is equal to 100. 100 minus 4r by 3 pi. So that will give the distance from the centroid to the OY axis. So 100 minus 4r by 3 pi. That will give the length of the centroid. Position, it will give the position of the centroid with respect to the OY axis. So here x3 is equal to 100 minus 4r by 3 pi. That is equal to 85.13 centimeter. And now next you have to calculate y3. So for the quadrant, this distance is 4r by 3 pi. You have to get the distance from the centroid to the OX axis. This distance is equal to 135, that is the total length minus 4r by 3 pi. Y3 is equal to 135 minus 4r by 3 pi. R is equal to 35, that is equal to 120.13 centimeter. So now the fourth figure is the triangle. So for the triangle, with respect to the OX axis, y coordinate is h by 3, where h is the height of the right triangle, and x coordinate with respect to the OY axis is b by 3, where b is the base width of the triangle. So now you have to place the triangle like this. So now this length is equal to h by 3 and this is equal to b by 3. So you have to get the distance from the centroid to the OY axis, that is the x4 value. So x4 is equal to this length, that is b by 3. So here b is equal to 35. So x4 is equal to b by 3. b is equal to 35 by 3, that is equal to 11.66 centimeter. So next you have to get the distance of the centroid from the OX axis. So this length you have to get. So total length is 135. You have to deduct this length h by 3 to get this value. So y4 is equal to 135 minus 35 by 3, where 35 is this height. This height is equal to 35 h by 3. And that is equal to 120.13 centimeter. And the last one is also a triangle. So for the right triangle, with respect to the OY axis, x coordinate is b by 3, and with respect to the OX axis, y coordinate is h by 3. So here you have to place the triangle like this. So x coordinate is the distance from the centroid to the OY axis, that is x5 is equal to this length. So this total width is equal to 100 minus b by 3. So x5 is equal to 100 minus b by 3, that is equal to 100 minus base width. Base width is 30 by 3, that is 90 centimeter. So now next is y5. So y5 is the distance from the centroid to the OX axis. This length is equal to h by 3. h is equal to 70. y5 is equal to 70 by 3, that is equal to 23.33 centimeter. So now you have to write the equation based on the figure. So here x coordinate is equal to a1 x1. a1 is the area of the rectangle, x1 is the position of the x coordinate of the rectangle. So that minus a2 x2 minus a3 x3 minus a4 x4 minus a5 x5. So you have to write the equation based on the question, then only you will get mark. So a1 minus a2 minus a3 minus a4 minus a5. So you have to substitute all the values. You will get the answer as 44.84 centimeter. And y coordinate is equal to a1 y1. a1 is the area of the rectangle, y1 is the y coordinate of the rectangle, minus a2 y2 minus a3 y3 minus a4 y4 minus a5 y5 divided by a1 minus a2 minus a3 minus a4 minus a5, that is equal to 56.91 centimeter. So this is actually 14 mark question. So for the question, this equation carries 1 mark. So altogether you will get 2 marks. Then for each values, that is area x1 y1, a2 x2 y2, and all this value carries marks. So you have to write all these values separately, and then you have to substitute and get the final value.